Hello, this is Jordan Glutch doing the Module 2.2 presentation for ASCI 260. Today we're going to be talking about the human command/control element that makes up part of the 6 elements of a UAS. We're going to be talking about why it's important and how it relies and is important in regards to the other 5 elements, which are the unmanned aircraft itself, the communication system or data link, the payload, and its launch and recovery of the aircraft. So without further ado, let's get started. What is the operator's role and what is the operator in relation to the UAS and all the other systems, or all the other elements rather? So the operator is effectively who is in control and who has direct authority over the UAS or the drone, and therefore they are the ones who are effectively giving it orders or directly controlling it in its flight. UAS systems range in size from large aircraft such as the MQ-1 and MQ-9 Reaper and Predator drones, down to what could be described as the size of a small bird, equipped with a camera and used for reconnaissance on a small scale by foot soldiers. These are all operated via different methods and with different intentions and mission profiles. However, the core concept remains the same. There is an operator, there is an aircraft, there is a way the operator is communicating with the aircraft, it has a mission, and it needs to go and come back, or at least complete its mission before not returning. So let's talk about how the operator interacts with the aircraft. Now, this can range anywhere between using a phone for a small quadcopter, using a RC controller module for something larger, or using a dedicated suite designed by the company that produces the drone for, say, a quadcopter with a gimbaled camera that can be controlled independently of the drone itself. There are different suites that get used for different applications and different airframes. And of course, there are the large trailers used by the military to control their larger drones, in which there is a sophisticated suite used for plugging in GPS coordinates and sending the aircraft there before doing weapons employment or reconnaissance. Regardless of the method used to link the operator and the aircraft, the important thing is that this link exists. Ideally, the control system that you'll be using when operating a UAS will be the ideal one for the situation. Ideally. You wouldn't want to operate an RQ-9 Reaper with an iPhone. So this brings me to a point I'd like to make in regards to this aforementioned link between the operator and the aircraft, which is ergonomics, or in other words, the human-machine interface. Now, what the human-machine interface is how the human interfaces with the machine. So, for example, in your car, your steering wheel, pedals, gear selector, and your instrumentation, so your gauges, these are the human-machine interface in your car. In an aircraft, they are the yoke, the throttle, the rudder pedals, the instrumentation as well. And on a UAS, it is how you control the aircraft. So this could vary anywhere, like I said, from the iPhone to the trailer. And these are designed with the mission profile of the aircraft in mind. Without a proper human-machine interface in place, the aircraft is not going to be able to operate properly. It is not going to be able to be used effectively in its role. The payload, or what the drone is carrying, differs wildly depending on the mission profile for the aircraft and the type of aircraft it is. Obviously, a larger aircraft will be able to carry heavier, more sophisticated payloads than lighter ones. So these payloads can range anywhere from larger battery packs for extended flight hours, cameras and sensors of differing levels of sophistication, and even weapon systems such as the AGM-114 Hellfire, which itself interacts with these more sophisticated camera suites in order to attack targets from a distance. In terms of takeoff and landing for different drones, this is governed by the airframe and the application as well. and also by the operator in a sense. Larger fixed-wing drones will require its own airstrip, or in the case of naval prototypes, a carrier launch system. And in the case of smaller quadcopters or helicopter-style drones, all it needs is enough space to take off and land safely vertically, considering that they are helicopters. As unmanned aircraft become more sophisticated, so must the link between the operator and the aircraft become more sophisticated. This is why concepts such as the cognitive human-machine interface and interactions, or the CHMI squared, is being presented as an alternative, or rather a solution, for the increasing complexity of unmanned aircraft. According to researchers at the Journal of Intelligent Robotic Systems, what this more advanced form of human-machine interface proposes is more autonomy for the unmanned aircraft, and they believe that it will be beneficial in separation assurance and collision avoidance. They believe that a higher level of autonomy in the aircraft will effectively improve their performance, reduce reaction times, and give the operator more time to operate the aircraft rather than be focused on flying it.